Hello BlackHat, hello everybody. Welcome to my presentation on Nebula, of Nebula on BlackHat Arsenal. For the next 30 or so minutes I will be explaining to you what Nebula is, what it can do, and how it can help you with your assessments on your own infrastructures. Before that, a bit of background for me. My name is Bjorn Proko. I'm a security engineer, mostly focused on infrastructure security and cloud security. And also lately, I've been working on DevOps and DevSecOps, different components they have, how they can be breached, how they can be secured, all of those stuff like that. As for Nebula, Nebula is a cloud pen testing tool which right now offers AWS, enumeration, exploitation, penetration testing, privilege escalation on AWS, but I'm planning on making it a multi-cloud pen testing framework, and also being able to enumerate other components of DevOps like Kubernetes, Jenkins, I don't know, like the whole CI/CD chain. As I said, Nebula is an enumeration, exploitation, post-exploitation, privilege escalation tool, and also has the reverse shell that does penetration testing on IAM, STS, S3, Lambda, SSM, Route 53, and ECR. Those are the services that it enumerates right now, or that it checks right now, with other services coming on the way. Another thing it has is privilege enumeration, so it checks privileges of users. It can change the user agent to avoid detection. It has the reverse shell, as I said, on Python currently, but I'm working on a reverse shell on Go to make it cross-platform. And the reverse shell itself right now also has a post-exploitation enumeration option that enumerates the system, if it's a container or not, and other components of that. We will see that later on the presentation, how it works and what does it show. Nebula is a modular based tool, so you can easily build modules. I have also included a template on the module directory, and I've practically included almost everything that you need to have on that, plus the design, which is automatically, it is generated automatically from the JSON output that the AWS API generates. So it's practically really easy if you want to contribute. The version it is built on is Python 3.8 and 3.9. I started with 3.8. Right now I'm currently working with 3.9, but it works on both. It uses Boto3 because it's practically is the only AWS library, but it's actually the best one till now. It's really updated with everything. It's really well maintained and really well documented, so that's why I use that. It uses termcaller for the design and PyPager for pagination, because there are some cases where you would have quite a lot of information, so you would need the pagination. The variables or the options of all the modules can be required or not. They are grabbed by the tool automatically from the module, and they are stored on the module in the form of a dictionary, so they can be easily grabbed by the tool and you don't have to do much manual work. As I said, the pagination is done by the PyPager, and it uses less to show the paginated information. This is the template. The template has the variables, which are all the options that you have. It has information about the author. If you want to contribute, you are more than allowed to set your information here, and I will be promoting you. It has the AWS command, so if you also want to try the AWS CLI command for a certain module that you are using, then you can do that. It has the description, of course, and the exploit function, which is like the main of each module, and is the one that will be called each time we say run a module. This is what Nebula can do. This is a diagram of all the functions that it can do, which is running Nebula, and at the running time it will try to gather information, it will try to gather credentials from the AWS folder. It will get commands, and it is written to also execute commands on system, so you can easily do cat ls for your own easiness. You can set credentials, you can use credentials, you can remove credentials if you don't want, you can dump credentials on the system, and you can import credentials from a file on the system directly to the tool. You can use a module, you can set options to the module, and you can run the module. And it has the reverse shell. You set up the listener, then you generate the stager, and you send the stager to the target, and if they run it, you will get the call back. And also you can also set up the user agent on another on something either custom or just randomly chosen by the ones we have on the tool. That way you can somehow bypass some defenses. Now, as for the AWS, we need to clear this out first. AWS offers quite a lot of services. As I said, we have a list of services that we check. The authentication on that is done by secret key, access key and secret key, access key, secret key and session token for the roles, and password when you have access to the login profile, so when you have access to the dashboard, to the web page. You are allowed to do penetration testing on AWS infrastructures as long as what you are testing only affects you, does not affect the AWS. We need to get this cleared because there are people that have been asking me why haven't I been using, haven't I built modules for denial of service and modules that change too much stuff. We cannot do that even if we want. We cannot just do a denial of service, because if we crash something, it might affect the company. We cannot do much port scanning, and not anything that will practically do anything bad to them. But we can change anything we want on our infrastructure, and we will see that we will do that using Nebula. As for the reverse shell, Nebula offers a reverse shell on Python, which aside from the fact that gives you access to the target system, allows you to enumerate the system, to get information on the metadata, gets the user data of the instance. If it has an instance profile, it will get the credentials of the instance profile. It will check if we are inside the container or not. If we are inside the container, it will try to check if we are on a privileged container and if the Docker sock is mounted. Also, it will check if the Kubernetes token is mounted. It will check the environment variables for sensitive information like Kube, Kubernetes, AWS, GitHub, token, stuff that are usually put inside, are put in environment variables. It will also find information on the user and the machine. And there is another option which I'm working on right now that will allow a user to run binaries from memory. Binaries that are on the attacker's machine from memory directly to the target's machine. Each shell or each agent that calls back to the server is called a particle on Nebula, and they are all listed as the same way you'd see on another C2 server. Now let's try this. We have our own machine, our target machine on this IP, our attacking machine on this IP, and our target machine this. So we have two different machines on the cloud, and we will try to get access from this one here, and then we will try to get access from another system which is on inside the Docker, which has the Docker sock and is privileged inside the same target machine. First things first, we set up the listener, which requires the port to be set up, and if you want, you can set up your own, you can insert your own encryption key. If you don't, it will be auto-generated and the traffic will be encrypted using XOR. We'll just set the port to 443 and run. Right now we have a listener running and we have the encryption key. Then we create the stager. Now the stager requires the encryption key, the output file, which will be the name of the binary or the name of the agent that will be created, the format, which in our case will be ELF, can also be just Python, the port and the host of the C2 server. Now the host will be our own server, and the port will be 443 as in the listener. We will name our own agent and the format will be ELF. Now it will generate. Okay, so it is saved here. If we look, we have the agent there, and if we go there and start a Python HTTP server, we can allow the target to access that. lo and behold, we have an agent. If we do show particles, we can see that we have an agent calling to our server. So this is the machine. If we do a shell check environment, we can see that we are inside an Ubuntu, 64-bit Ubuntu, with this internal IP address, which doesn't have much sensitive information on the environment variables, but has some user data, which has very, 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 very sensitive information, and some really obfuscated, really hard to decode and really important code, and the instance profile, which is the access key, secret key, and session token, which we can use, and has the role name EC2 SSM role. Also, we also get the account ID in case in this process we didn't have that. Now let's try to do that from a container. And we are root. We get root access, but we have root access inside a container, which doesn't mean much. As we can see here, it says Docker socket exists because it was mount, and since it's the process is number one, it's bash, it's not init or systemd, it might be a container. Another way it detects is by the host name. The containers have 12 characters, which are letters and numbers, but there are always just randomly generated, so it's another way it detects it. And it also got information on the metadata. If the target had configured metadata version 2, we wouldn't be able to access this from the container, but we would be able to access that from the host, because I have configured the code. I have written the code to also try to get a token. If they had set up version 2, we wouldn't be able to do this from the Docker machine. Now, lastly, this is also saved here, so that you can later on use it on your report. So yeah, this is the reverse shell part. As for ongoing and future plans, I'm planning on expanding the tool to other services like CloudTrail, finding ways on how to disable CloudTrail on one or multiple regions, depending on how it's configured. Guard duty, there are quite a lot of ways guard duty can detect you, so I will be working on how to bypass them. ECS and X, because they can help us with containers, and containers always have sensitive informations. SES, and I'm currently working on a module. I'm almost done on a module that will use an account that can send emails using SES, and send an email that I will be providing, so that you fish users with a legitimate email from the company, so that it's more trust, they can trust it easier. and also RDS because as a database it contains information, because it's, it's just the storage of all the informations. A Go reverse shell, which will allow you to cross cross compile it to different Linux distros and also different operating systems, including Windows, because right now Python doesn't have that functionality. I mean, you can build that, but you need to have another system just to build the reverse shell, privilege enumeration and privilege escalation modules. So I'm working on a module that will try to enumerate if a user has the necessary privileges to escalate to a higher privilege, and also work with those modules that I will use after I've enumerated the privilege escalation, and Azure and Azure AD modules. Now I'm working quite a lot on how you can attack Azure and Azure AD, of course, and I will be including some modules for them too. As for the future plans, and I'm talking about probably next year, I want to work on a team server, something that, a service that will allow different teammates to connect to it, and then all the output will be saved in one place so that they can have collaboration for everything. All the agents will connect to the same server, and each of them can connect to all the agents to send commands to them or do whatever they want inside them. Plus they can also do the assessments using the API and get the output inside the server. And also including other cloud providers like Google Cloud Platform. As for other similar tools, Pacu is right now is the go-to tool. We have to say that is the go-to tool for AWS penetration testing. It does quite a lot. The guys from Reconnaissance are really nice. I actually started doing Nebula while reading the book written by them, so it's a must. It's a must used tool. It's something that you should at least try. Scout Suite, it's another tool that will help you find misconfigurations on your cloud infrastructures. AWS Pune is the one that somehow started it all. We could say that it's not a tool per se. It's a collection of different scripts that does different stuff. So it's not like a whole framework, but still does the job correctly. And the presentation that was given for that is something that I also used for some modules on Nebula. And CloudGoat, while this is not a penetration testing tool, it allows you to set up vulnerable infrastructures so that you can test your knowledge, and you can test your own tool or your own modules. So this is another one that you should try. And as for references, as I said, I started Nebula while I was reading the hands-on AWS penetration testing with Kali Linux. Really good book. It's an easy read, will help you a lot. And Hack Like a Ghost, that one is a really nice book too. As for other public information or references, you have the Reconnaissance blog. They do a really good job explaining everything they do, and also have the privilege escalation, two privilege escalation blogs, which I'm working on for the module I said. We have the Hacking AWS end-to-end. This one is written by the guy that wrote AWS Pune. And we have the Bottle 3 documentation. As I said, really nicely maintained, so you will find everything there and really well explained. And the AWS CLI, in case you want to cross-check with a bottle 3. So this is my presentation. Thank you very much for attending it. In case you have any questions, please write them on the chat, or I don't know. And thanks. Goodbye.